In Physics Lab 2 line charge model. In this lab, we used information from Lab 1 to help us model the electric field on the top tape by considering the tape as line charges using glow script. The goal of this experiment is to find the charge necessary on each tape to keep the top tape floating in midair above the bottom tape using a distributed charge model. This is achieved by summing the differential electric field created by the differential electric charge on bottom tape exerted on the top tape. Then I calculated and summed all the differential force on top tape to get the net electric force, which should be equal and opposite to its gravitational force such that they cancel out to zero. Recap of the charge tape experiment. So two tapes were torn apart such that there is excess and deficient charge on each tape. One tape was able to float above the other due to the electric field the bottom tape exerted on the top tape. We estimated the separation distance and assumed the tapes as point charges to calculate the charge on each tape, and we used Newton's second law such that in equilibrium the electric force on top tape cancels with its gravitational force to get the charge on each tape. The physics involved in this experiment is Newton's third law, where the electric force on each of the tape is equal and opposite. Yes. And for Newton's second law, we know that since the top tape is in equilibrium, the net force should be zero, which means that the electric force and the gravitational force on the top tape should cancel out to zero. How did I get the model? I borrowed the data from Lab 1 and the function to calculate electric field from Lab 0. This function takes a charged particle object and the observation location, such that I was able to obtain the magnitude of the electric field from a point charge. This is part of the base code provided to us. This is important because it modeled the tapes as line charge instead of point charge. Another important piece of the code is this part. This is where the net force and net electric force and net electric field is calculated on each differential charge on the top tape. So this is the result of Lab 2 from the glow script code I just showed. The magnitude of the electric force and the magnitude of gravitational force cancel out, as you can see. The yellow is the gravitational force and the white is the net electric force. So I started out using a point charge we found from Lab 1, and I incremented iteratively until I found the charge on each tape such that the magnitude of electric force equals to the gravitational force. As you can see, there's a difference, and the charge on the line charge model is about 6.4 to the negative 9 coulomb larger. This is the code if you would like to see the model. So I kind of already answered this question. Comparing the two models with the line charge or point charge, we found the difference to be 6.4 to the negative 9. So why do they differ? And which value is more likely to be closer to the real value? This difference in charge is expected and tells us that in real life, the charge on the tapes should be bigger than the point charge model result. This is because in real life, the charge on the tape are evenly distributed and better resembled by the line charge model. So the line charge model is closer to the real value. So this is my video on this lab. Thank you for watching. Bye bye.